All right, we're continuing with two-column proofs, looking at exercise problem 40. Again, just recall what we saw, that whenever you have premises, you're combining them with conjunctions, and they should logically imply the conclusion. So when we look at problem 40, we see four sentences. I've broken them down here for you. It says, if a filament is made of copper, so I already know it's going to be a conditional statement with that if, even though the word then is not there. And I'll say a filament made of copper, I'll call that C. It will conduct electricity, I will use E. Second statement says the filament is made of copper, again, repeating the first statement C, or it is made of nylon, which I will use N. If the filament is made of nylon, then, again, a conditional statement, it will melt when it is heated. I will use the letter M. So you can see we have four variables, so a very large truth table, so that is why we're going to do two-column proofs. Therefore tells me now we have reached the point of our conclusion. So indicating here our premises, now our conclusion. Therefore, if the filament does not conduct electricity, so it's a conditional statement. That's an arrow. Horrible arrow. Therefore, if the filament does not conduct electricity, well, we said conduct electricity is E, so if it does not conduct electricity, is negation E. It will melt when heated, which we said was M. All right, so look at the conclusion we have and what we want to get to. We want to start with an antecedent of negation E, and the only place that could come from is this E, and end with the consequent of M, which will come from here. So you can see a series of steps that will need to be taken. As always, start with listing your three premises. And the reason behind those is simply we must list our premises. So, as you know, as before, you're going to want to combine these premises together and see what rule you can use. Now, one thing we know right away is any disjunctions we want to change to a conditional. And I see a disjunction right here. So let's go ahead and start by seeing where that can get us, because unlike the problem before, I see no single variables, so I see no use of modus ponens or modus tollens. However, I do see several conditional statements and one that we will need to change to conditional. So according to the rule that takes a disjunction to a conditional, or DC1, we want to do that to step number 2. So if I change this disjunction to a conditional, what I end up with is the first variable being negated. Now I have this. So I've eliminated step 2 and have now transformed it into number 4 here using DC1, disjunction to conditional, which the first variable is changed. All right, so now we have 3 conditional statements, as you see. Again, I'm not really seeing anything I can do, especially no modus, ponens, or tollens. However, one rule that we know that uses conditional statements a lot is hypothetical syllogism. But keep in mind that middle variable must match. Well, I see only one link between these, C, E, and M, not C and N. I see the N's and I see the C's. So I could combine these two with the N's right in the middle. So let's go ahead and do that. And again, you could do different steps for this in different orders, in a different order. So anything here is fine. So I'm going to put this one first because I know that not C, then N, and if N, then M, keeps the two N's here in the middle. All I've done here is a conjunction. Don't get ahead of yourself and put hypothetical syllogism because we haven't applied that law yet. All we've done is the very important step of conjunction between what appears to be number 4 and number 3. So I've used 4 and I've used 3. All right, now I can see here that this will logically imply something else. And when we eliminate that middle variable, what we end up with is if not C, then M. And how did we get that? Well, we used, of course, the law of hypothetical syllogism as applied to step number 5 there. So now we're done with 5. All right, so now we're left with just statement 1 and statement 6. And as we saw before, the best rule to use when combining two conditional statements is hypothetical syllogism. However, that will require that the middle variables, just like here, match. And really the only link I have here is a C. So obviously something's going to need to be flipped and negated in order to give me these C's to match up. So the question is, which one should we flip and negate? Well, keep in mind that our conclusion needs to have not E as the antecedent and M as the consequent. Well, here M is already the consequent, so if I flip and negate this, I would be placing M in the wrong position. I want not C, negation C, as an antecedent, and negation E as the antecedent, and the only place E comes into play is here in step 1, which is now the consequent, so I'm going to need to bring it to the front as an antecedent, but not only switched, also negated. So if you look at step 1, statement 1 carefully, you can see that there's a law that allows me to switch and negate these two things and know that they are logically equivalent. So not E, then not C becomes the outcome when I take number 1 and apply the law contrapositive. Again, you can see this on your cheat sheet. We have the contrapositive, which are equal to each other or imply each other, in which they are flipped and negated. So I simply flipped and negated statement 1, premise 1, which I'm now done with, and now I have statement 7. So now you can clearly see I have two statements, 7 and 6, which can be combined in a conjunction in that order because I want to put 7 first and combine that in a conjunction with 6 for the reason that it keeps the two negation C's in the middle, which of course we know in the next step removes them and leaves us with, if not E as the antecedent, then M as the consequent, according again to the law of hypothetical syllogism. So I've used 7 and 6 as a conjunction, and I've turned 8 into 9, and now I'm left with one single outcome. If negation E, then M. Now that I have one thing, I want to compare it to my original statement, and I could see if negation E, then M was the goal for the conclusion, which I've reached, so now I've successfully validated this argument. Thanks for watching.